Welcome back. We're continuing our discussion today on statistics and probability. I'm Jason Grindstaff, and in our previous videos we've done inferential statistics and we've begun reviewing some probability concepts. In our most recent video we looked at introducing the concepts and discussion on combinations and permutations. And in our final video on combinations we're going to look at a little bit more advanced this problem that'll help you kind of work through how to calculate combinations. So here we're working with our example problem of probability. And in this example we have a committee of 11 people. We've got 6 women and 5 men, so 11 total. And what we're being asked to do is figure out the probability of selecting a committee of exactly 2 men and 3 women. All right. So anytime we have an example problem of probability, remember, let's always get back to our probability formula, which is the number of favorable outcomes divided by the number of total possible outcomes. So in this case, let's look at and solve for number of total possible outcomes first. So here we're being asked to solve for how many combinations of 5 out of 11 can we get? So in that case, we've got 11 factorial divided by 5 factorial, 11 minus 5 factorial. So if we work this all out, all the way down to 1, and then we get 5, 4, 3, 2, 1, and then we should get 6 factorial. All right, our 6 factorial here is going to cancel with our 6 factorial there. And the rest of our formula, if we just multiply this out, we should get, and you can check my math as well as you're following along, 55,440 over 120, which is going to reduce down to 462. So in essence, what that's telling us is that out of 11 people, there are 462 combinations of 5 that we can get, and that's going to be our number of total possible outcomes. So now let's figure out number of favorable outcomes. Well, in essence, what we're saying is we need to calculate 2 combinations here because we need a committee of exactly 2 men and we need a committee of exactly 3 women. So let's calculate each of these separately. So how many men do we have? Well, remember we said we have 5 men and 6 women. So let's remember that. 5 men, and we have 6 possible women to choose from. So at first, what we need to do is we need to figure out the combination of 5 men choose 2, and then in essence what we're going to do is figure out the combination of 6 women choose 3, and then we're going to multiply those values together. So let's calculate this one out first. So we've got 5 factorial over 2 factorial, 5 minus 2 factorial. Five factorial again, 2 times 1, and then we're going to get 3 factorial. The 3 factorials cancel out in this case. And then we should be able to come up with 5 times 4 divided by 2. So we're going to get 20 divided by 2 is 10. So what that means is there are 10 ways to choose 2 males out of the 5 males. Let's do the same thing for the women here. All right, so we've got 6 factorial divided by 3 factorial, 6 minus 3 factorial. 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, and then we get 3 factorial. The 3 factorials cancel out. All right, and this should give us 120 divided by 6, or 20. And then as we work our way through this problem, what we in essence need to do is we need to take these combinations. So let's write out our formula so that we conceptually know what we're looking at here. Number of favorable outcomes. So we've got the combination of 5 choose 2 times the number of combinations 6 choose 3 over the combination of 11 choose 5. We've already worked this out to be 462. And we got 10 times 20. So 10 times 20 is 200 divided by 462. Reverse works its way down to 10 out of 23. And we come up with a final probability of 0.4329. And that's equivalent to 43.29% of the time, drawing at random, we will get exactly 2 men and 3 women in our committee. So it's a lot of work. It's a lot of, I understand that it's a lot of math, but just keep working with the math with these. The more you practice, the better you're going to get at it. And as we move forward, we'll kind of take a look at some example problems of permutations, but that's for next time. Thank you.